So we're here to talk through this Japanese sums variation with a Latin square constraint. That constraint, unlike a typical Japanese sum, tells us that every one of these rows will use 6 digits and also have 3 blackened cells, and that will help us, particularly with the 3 sum clues. For instance, let's take this top row. We can mark that the 1 is a single digit, the 3 is a single digit, and then the 17 will use 4 digits to go. We already have where 2 of the black squares must sit, which is between these clues, so we can actually mark in the grid something like I'm doing here, which says that a 1 is in one of these cells, then a blackened cell, then a 3, then a blackened cell, and we can mark off 3 of the used cells from the 4. We don't know if it will take the left or the right side, but having marked those in the grid, we're pretty well set to start thinking in different ways about the columns. One of the more obvious choices up here, the 4 could have been 1 or 2 digits, but it can't be 3 digits. So when we know that we use this cell and we know we use this cell, we can't use the one in between. So this is one of the first things we can mark. And say the 9 has to take at least one more cell. We have an unused here and the 8 finishes out. This 9 needs another cell. 17 has to be either 4 or 5 digits as a sum, so we can mark this. But one of the nice things that marking some of these choices in the middle of the grid allows us to do is think about the consequences of particular placements. A 5 can be in 1 or 2 cells. It would want to, if it were here, be exactly in 1 cell, couldn't continue down, it would have to be a 5 here. The 3 sitting here would cause a lot of problems. First you'd have 3 plus 2, need another 2, we would have this cell being used. Regardless, what we can say is the 3 has to come to the left, and we can force this into the grid. We need at least 2 more from this sum. 13 left over needs at least 4 more. We filled this cell, which nicely gives us where this 21 sits across. And we have something like a 6, 5 left over with the 3, 4 over here. Knowing that the 9 is just 2 digits tells us the 12 is 4 long, and so we can actually mark that into the grid. These 4 cells at least use the middle 2. We now have 4 over on this 21, so it can't come all the way over to here. And then we get another set of deductions we can start to put in. The 4, at least by sum, is going to be down here. The 6 by sum is going to be here. We'll have a gap. Something like that. The next place I want to look is probably this 12, 4, 5. One of the reasons is we now have filled a lot into this row. The 4 wants to be a single cell, but the 12 needs to be at least 3 or more. So the 12 is going to include this space. If the 12 went all the way over to here, it wouldn't leave enough room for 2 more sums. So these 2 cells have to add up to 4. 1 and 3 here remove any of the 2 cell options for the 5, so this is just the digit 5. And over here we're going to have 2, 4, 6, 2, 4, 6, 2, 4, 6 left over. 11 can only be as many as 4 cells, so this is unused, and the 6 gets pushed down. We're just looking at the adjoining clue. The 6 is going to need to take a 3. We're going to have a 2 somewhere, then a nothing, and then this 10 is going to be 3 digits long. It's going to be 1, 4, 5 in some order, and we don't know more than that yet. The 4 at the bottom is going to be just a 4. That leaves just a 2 for this cell. We have 3, 5, 3, 5. And I'll just do some cleanup. So next place that's reasonable to look is actually this column. Why? Well, this 2 is going to be very hard to place, and I see a 2 in the grid, and so you can ask yourself, is the 2 this 2? It can't be. It's going to push itself over 1 spot. 14 needs at least 3 cells to use. This is a 2. Again, we use all 3 digits, or all 6 digits in a column, so we can mark this as part of a sum. And so we've effectively marked off that space. Done similarly well over here. We now have at least 1 more cell coming down to get 4 total in that group. Thinking like we did at the top, we have 2 of the black cells already used in the space. what we do know is that the 6 can't be alone on just this cell, so the 6 has to reach over one more. Why is that? Well, 6 is already above here. If this were 4, this is 4, 2. If this is a black cell, then we need to have 6 reach the 11 and then 4. So having this be used is a first step to get into this row. We're going to be able to see pretty soon actually, and I think it's going to come from here. This 4 is not going to come from 1 plus 3. It's going to have to be a sole digit. The only place a sole digit can be is down here. So we're actually going to be able to force that immediately. This now we see has to be separated. 11 needs at least 3, and this is going to have to be 1 plus 3 because we've already used the 4 in that row. So this is 2 of 5. We can fill that in actually. We have 3, 6 left over, 3, 6 left over. This 8 coming up needs to have 1 with 5, 1 with 5. That's going to force this up here. 9 is still going to need at least one more cell. This will need one more cell. So this is 16 plus just a 5 with an unused cell. 17 is the remaining sum here, so we can just cancel all this out. It takes us over like this. Let's look at this column for a little bit. The 6 is going to be whatever sum is up here. It could be just a 6, it could be more than that. The 5 has to be next, and then there's a 10, and the 10 is going to start from this bottom cell and use at least 2 more digits. 3 plus 6 is not large enough for it, but what we end up seeing is once we mark it as 3, it actually will use 4 digits. So this is going to be 1, 2, 3, 4, of which the top cells can only be 1 of 4. This will be 5 alone, and this will be 6 alone. We actually have that cell marked. The cell can be marked, and we can finish off these clues. We had marked 1, 4, 5 down here, so this is where the 1 is. This is the only spot left for the 5. This is a 4. We can mark this cell as used. 9 is 4 plus 5, but 4, 5 is already used here, so this is going to be 3 with 6. Over here we're going to have 1, 4, 5 left over. We already have 1 and 4 in this column, so we get something like this. Finishing this out, we need the 6 with the 3, and the 6 is already there. This 3 comes over and cancels my note. We've marked this cell as used, so we can actually come across and finish the 21 clue. That pushes the 5 down, comes over here. 5 and 1 cancels this way. The 6 cancels these clues over to the left. This has left over 1, 4, and 2. Can only come this way. This is 1 and 3. This is the last spot for a 2. This column needs 6 and 3. Just put that in. We've used all the digits in this row, so I'll shade it off. This has a 3 left over. This needs a 6. This 4 cancels over here. We have 2 of 5 left in the second row. The 5 forces this. We have 2 of 1 left here. We have 1 with 4 here, and we have 4 with 6. Finishing out. So at the end, this was really Sudoku-like notation, or Latin square-like propagation of digits. You could see through the puzzle how I was using my notes to help me, but I think in this puzzle the thing was really most informative was how to write some of these small notations in the middle of the grid, like this 2 here, so you could actually use the intercepting logic of row and column clues more readily by looking into the puzzle. Not sure that this is a particularly challenging Japanese sum, but since we don't have too many on the side, I think that adds to its difficulty. We have some much more difficult versions of this puzzle coming up in the future, and maybe we'll have another talk through then when we see some more challenging arithmetic going on in these puzzles. Hope you enjoyed Serkan's challenge, and we'll see you again soon.